The 2.5, we are going to deal with the homogeneous equation. Okay, that's it. Homogeneous. Again, is the equation of a person. Homogeneous equation. Okay, to define it, I give you two different definitions. You in your book, they talk about one definition right away. But I give you two. One of them is coming from calculus 3. Okay, that give you a better chance to recognize this equation right away. So we get something from calculus 3 first. Okay, when a function of two variables is going to be called homogeneous. So we are going to borrow this definition. We have seen it in calculus 3. So recall that function of a two variable, the function f of x comma y, two variables, is said to be homogeneous. Said to be homogeneous. Yes, of degree n. Of the degree n, if it satisfies this condition. So the condition is if you replace x and y by t times x, t is a number. Replace x by 5x, y by 5x. Then if you can pull out that 5 out of the function as a factor, in that case, it's going to be homogeneous. If you say it's a homogeneous of degree n, this means that factor 5 to the n would be out. So it's going to be homogeneous if we change the x into the t times x, and you change the y into the t times y, and you'll be able to factor out the n power of the t. So this is going to be t to the n, okay, t to the n, f of x comma y. So homogeneous, if you change the variables into a scalar multiplication of the 2x, you get this one. And this is going to be true, okay, for some n. You know, it's going to be true for x and the y, and t is going to be any in a scalar. Okay, so for some n, scalar t. So in this case, we say the function is homogeneous. Let's get practice on this one first, and then we come back and change it to the format of a differential equation. Okay. So, for example, the first one, suppose this function is given to you. F of x comma y is equal to the x squared minus 3xy plus 5y squared. Look at the power of each term. The power of the first one, as in algebra, degree is 2. The second one in algebra, when you get two variables, you add the powers together. So 1 and 1 would be 2. And this one is also 2. So all the powers are 2. So quickly you can realize that this is going to be a homogeneous function of order 2. Okay, you can try to see it. Okay, this is the way we identify quickly. Then this is it. Replace x by tx and the y by ty. Substitute. So if you substitute here, it's going to be tx all squared. Okay, minus t times x, t times y. That's 5 times ty squared. If you square it, we can factor out the t. So that gives you t squared, x squared, is 3t squared xy. That would be plus 5t squared y squared. Quickly, you can pull out the t squared as a factor. So if you pull out the t squared as a factor, that gives x squared minus 3xy plus 5y squared, which is the original function. Okay, so we prove that f of t times x and the ty is equal to the t squared f of x y. Okay, so this function is homogeneous. It's homogeneous of the order of the two. Okay, so f is going to be homogeneous. Okay, homogeneous of degree 2. Okay, so this is the sort of function that we have. So quickly we can identify it really. I give you the second one and you're just telling me if it's going to be homogeneous. Okay, the second one, it's going to be f of x comma y is equal to the 6xy to the third power minus x squared y squared. Look at this one. Check the power of each monomial, the degree of each monomial, each term. So this one, degree is the sum of the degrees. 1 plus 3 is 4. And this is 2 plus 2 is 4. So this is homogeneous of degree 4. I need to check it out. Okay. So if this is going to be the case, this is going to be, so it's going to be homogeneous. Yes, of degree 4. Any question? So they are going to be used from time to time for some purposes in calculus. Now differential equation. If a differential equation would give it to the format is what? mdx plus ndy equal to the same. This differential equation is going to be called homogeneous. If that function m and n, both of them are going to be homogeneous of the same degree. That's definition of a differential equation of the, okay, homogeneous differential equation. Okay, m and n. So the definition will be, it's not the way it's in your book, but I'm going to change it. Okay, so a differential equation, first of the first degree of the form differential equation of the form. Look at this one, m of, as usual, m of xy dx as n of xy equal to the 0. This is homogeneous. If this m and n, both of them, going to be homogeneous function of the same degree. So you just have a look quickly and you find out. Okay, so this equation is going to be said to be homogeneous. Said to be homogeneous. Yeah, homogeneous if both functions, m and n, both of them are going to be homogeneous of the same degree. Homogeneous of the, okay, of the same degree. Same degree. The way you check it, you just check the power of each monomial quickly to find out it's going to be homogeneous. So it's very easy to identify this function. Yes.
So with that previous example where it's degree 4, if that y to the third was like y to the 5th, then it wouldn't be homogeneous.
No, it wouldn't.
Okay.
The power must be kind of symmetric because you want to pull out that power of the t.
So each like chunk has to, sum of those powers has to be the same.
Yeah, that's it. Quickly have a look. Find out the right way. There's another method to the that's the way we can find out quickly. Okay, so for example, look at this one. Example. Look at the first one. Look at this equation. Equation is x squared plus y squared dx and plus x squared minus xy dy equal to this. Look at this. You see the first function is homogeneous. Homogeneous of what power? What degree? 2. And the second one. See, monomial again is the same thing. So both of them are going to be homogeneous of the second power, and therefore it's going to be homogeneous. Okay, so it is homogeneous. It is, okay, it's going to be homogeneous. Equation. Okay, if you like, you can, you don't have to, but I'll just explain it for you. M equal to the x squared plus y squared, and n equal to the x squared minus xy are going to be homogeneous. Just for your information. Of degree 2, or the same degree. Okay, so quickly be able to identify it. Any question? Give you another one. The one that you have in your book are nicely, they write down as a form of y prime, dy dx. This format also will be possible. Okay, so this is how you have it in your most of the problem. Okay, that you see there. And this one, the second one. In your book, you start with this expression, dy dx equal to 4x plus 3y. And this is going to be 2x plus 1. It's going to be on this format. You know that this top and the bottom are going to be your m and n function. As you cross multiply it, you get to the format that we talk about it, the standard. So just have a look. You see the top one and the bottom one. Top is homogeneous of degree 1. And the bottom one is homogeneous of degree 1. So quickly, just have a look, you find out that this equation are going to be, okay, this is going to be again homogeneous. Is homogeneous. Okay, that's it, homogeneous equation. That's it. Any question? Now, the way it's expressed in your book, this is it. If you look at this equation that you had, since they are homogeneous of the same degree, so what you can do is on the top, divide the top and the bottom by x. If you divide the top and the bottom by x, what are you going to get? The x would disappear. So the leftover would be y over x. So the top would be 4 plus 3 times y over x, and the bottom would be 2 plus y over x. In your book, they use this one as a definition. It says that because the equation that's going to be given to in your book are all of them of this format. So they claim that this equation is homogeneous if this equation can be written as a function of y over x. And the reason is the method that they're going to use, we call it the substitution method, you change it. But you identify that it is homogeneous, then quickly you can convert it. Okay, you can convert it to a function of y over x or x over y. It doesn't matter. And we usually go for the y over x. It's always possible. Because those powers, they're in each term, you have the same power. So you quickly be able to pull out one of the factors, okay? So this is a note just to connect what I'm talking about and what's in the book. So in general, and it's very easy to prove, of course. If you pick the proper t, then you can check that in general, any homogeneous function can be written as this one. Okay, so in general, every homogeneous, every homogeneous differential equation, homogeneous differential equation. Okay, homogeneous differential equation can be converted You can change it. Can be converted to the following form. To the following form. What's going to be the form? Have the dy dx on one side. On the other side, you are going to write your function as a function of y over x. Okay, this is going to be is a function of y over x. If you call it z, in that case, it's a function of z, and z is y over x. So from a function of a kind of two variables, you change it to the function of one variable. You quickly be able to, to do it. So, for example, let's try one. For example, if you check the first one that we did have, so if the equation is given to you of this form, remember x squared plus y squared dy x squared minus xy dx, okay, equal to the z. This is given to you. For example, you want to solve it. You recognize it's going to be homogeneous. So your next step is to write it down as a function of y over x. So what you can do is just cross multiply, it's just move it to the other side. So this is going to be x squared plus y squared. That's a dy. It's going to be minus x squared minus xy dx. Write it down as a dy dx, format of standard from your book, or the format that you're going to do it. So that gives you dy dx. What's going to be on the top? This is it. Now on the top, we get the negative x squared. Negative x squared, okay. Negative x squared in this case, plus, okay, the one that I have, it doesn't matter. Let's call it because I'm going to. This one, x squared plus xy. So I move it to the other side, I'm going to get the x squared plus xy. Okay, so I can write this one, negative x squared minus xy divided by what? X squared plus y squared. Let's cross multiply to get that one. Now I want to change it to the function of y over x. So what can I do is, in this case, remember it was, the degree is 2. So what we can do is we can factor out the, okay, there you are, factor out the x squared, or divide by x squared. Both of them are going to be the same. If you divide by x squared, that gives you x squared over x squared. And that would be minus xy over x squared. And this is going to be x squared over x squared. And that would be y squared over x squared. Simplify. What's going to be the result? If you simplify that, give you dy dx. Dy dx is equal to what? It's going to be equal to the minus 1. Okay, minus 1, these two would cancel out. Okay, so this is going to be minus 1, and this that give you 1 y over x. Okay, on the top, because I divided by that's it. Yeah, it's a negative 1 minus. Let me rewrite it. Minus y over x, and the bottom one would be what? Would be 1 plus. I got y squared x squared, so I change it to the. Okay, I made a mistake here. Yes,
Should be plus y over x, I think.
this one. I'm fine. It's going to be plus y over x all squared. Okay, so it's all right. So what I did, cross multiply it, and then I divided by x squared. Okay, so as you can see, the result is going to be what? The result is going to be a function of, okay, the result is going to be a function of y over x. So it's going to be f of y over x. Okay, so it's it's possible to change all these functions. All these functions quickly. You have to do this one to be able to solve the, solve. Yes.
Is there a specific reason why you divide by x squared?
Because I want to change a function into the function of y over x.
But is it always going to be x squared?
In this case, the degree is 2, so that's why you have to divide by x squared. Depends on the degree that you're going to have.
So it could be x to the 5, x to the whatever.
Depend on the degrees of the problem. Yeah.
Okay.
You see, that's the degree of it. The other one was, look at this one. What was the other one? Similarly, the other one was the second one that I gave you,
It's to the 4.
dy dx equal to, see, that's a 4x plus 3y over 2x plus y. You see, it's homogeneous of the first degree.
Right.
So divide by x. If you divide the top and the bottom by x, what's going to be the result? So that give you we do it quickly, okay? It's just I explain it. So I divide by x. See, it's a 2x over x and the y over x. Simplify it. So the result would be 4 plus 3 times y over x. And this is going to be 2 plus y over x. So as you can see, this is going to be a okay, so this is true interpretation of, but it's nice to recognize it first. You see, you recognize it by looking at those two functions and give it degree, then you have to change it. You have to convert it to be able to solve it. Okay. Any question? Now, the method that this section 2.5 in your book, they don't talk about homogeneous equation. It says solving the differential equation by substitution method. They give you this one and the Bernoulli equation that we talked about. So the way we did it, we just put it in the proper position, to talk about it. Now, how are we going to solve this equation? The way we're going to do it, you see this y over x, we are going to call it z. We call it z. If I call this one z, what is going to be f function? If I call this one, you see f of z would be what? F of z would be 4 plus 3z over 2 plus z. And over here would be the same thing. So what I'm going to do is I change this one into the y over x. Then you have to change the differential as well. So we do a little bit of substitution for the differential and eventually be able to solve it. So what I'm going to do, I'm going to prove it for you. At the end, you get a formula. You can use that formula, okay? In your book, suggest that, use that one all the time, but you don't have to. So how we're going to solve it? That's it. Solving homogeneous. If you substitute the z, result will be equation with the separable variables to be able to do it. Let's do it once, prove it, and then we use it. So how are we going to solve? Solving homogeneous, differential equation. Homogeneous equation. Okay, now you know that the equation can be converted. So your equation would be this one. Okay, suppose you want to solve this one. Suppose this equation is given to you. Suppose that dy over dx, you have done the algebra part, is equal to the f of y over x. And you want to solve. Okay, is a given equation to solve. Now, how I'm going to do it? Use the substitution C to solve the equation. Okay, to solve the equation. One can use, or one can apply substitution. Variable. Substitution variable, you see, is z equal to y over x. We go with the y over x all the time. If you go with the x over y, it's going to be the same thing. As soon as I put z equal to the y over x, then what's going to be the conclusion? And I cross multiply it, that give me y equal to, okay, y equal to the z times x. So I have these two. So before going and substitute the differential equation, I'm going to find, in this case, I'm going to find the dy. So when I go to the, see the term to the right would be a function of z. Then you have to do something to the term to the left. The term to the left is dy and dx. We want to do it with a separable variable. So what I'm going to do, I'm going to find the differential of the y as well. Then when I substitute it, it's going to be a differential equation with the separable variables, but in variables z and x. Then we can do it. Okay, so that's the idea. So let's find the differential of the y. This differential of the y. Y is equal to the z times x. Differential. Okay, find the differential, not the derivative. It's going to be dy is equal to, have to apply the product rule. Differential of the first one times the second one and the other way around. Differential of the first one would be dz times the second x plus differential of a second one times the first one would be z times dx. Okay, so this is the relationship between these differentials. Okay, go back to the equation, substitute. So what is the equation? Look at this. This is your equation. So start with the given equation. So what we have the dy over dx equal to the f of y over x. Substitute. What do you have? You have the dy. Substitute for dy on the top. So it's going to be what? I'm going to switch it to right on this one. Give me x dz plus z dx on the top. And this is going to be dx is equal to f of g, f of what? F of z. Any question? I just substitute. So what I'd like to do is we'd like to write it down as a, okay, equation with the separable variable. A little bit of algebra, I'm going to break these fractions first. Okay, so this is going to be x dz over the dx, okay, plus what? Plus z dx over dx is equal to the f of z. Okay, now I can simplify the differential of the x. It's going to be the leftover. The leftover is going to be x dz over the dx plus z equal to the f of z. Okay, because of dx and dx is simple. So move the z to the other side. So that give you x dz over the dx is equal to the f of z minus z. I want to change it to the differential equation with the separable variable. So I have two variables, x and the z. So I put the differential of the x and the x on one side, the z and the z on the other side. So what are going to have? So this is a kind of, you can multiply, cross multiply it first and then simplify it. So that give you x dz equal to the f of z minus z dx. Okay. So I would like to put the x and the z together. Okay, x, I have a dx and the x. So I start with the dx over x equal to, what I'm going to over here. Remember that was x times dz. So I have to put the z dz on the top, then f of z minus z down the bottom. Look at this equation. This is a differential equation with a separable variable. Because the variables are going to be, of course, z and x. You have dx over x on one side of the equation and the dz fz minus z on the other side. So in order to solve it, you know that you integrate both sides. So this is going to be, okay, the equation, this equation has separable variables. Has separable, okay, separable variable x and z. Integrate both sides to get the solution. Any question? Going to go to the next page. Integrating. Integral of the left is very easy. What's the integral of the left one? ln x, ln of the absolute value of x. Integral to the right, you have to find it. So it depends on the f of z that you're going to create in each problem. You have to bring it down here. It's going to be a rational function. So the possibilities are going to be maybe quick. U prime u, you do it right away ln function. Otherwise, you have to use the method of the partial fractions to be able to do it. So sometimes it takes a little bit time to be able to do it, but otherwise you are going to be fine. Okay. So integrate both sides to have this formula, and you can start with this formula. So I integrated, it's going to be dxx, and it's going to be dz f of z minus z. The term to the left is easy, so it's going to be ln of the absolute value of x to the left, and to the right is going to be dz f of z minus z. You have to memorize this formula, use it. So as soon as the equation is given to you, you have to find f of z. Then you simplify f of z minus z. Then use the reciprocal, bring it here. Bring it here and start working on this one. Okay? So the instruction is going to be, we are going to evaluate. Okay, this is it. We're going to evaluate the integral. Okay, integral, and using the fact that the z equal to the y over x. When you find it at the end, your integral would be depend on z. And you have to substitute for z. When you substitute for z, y is there. Just find it. So use z equal to the y over x to find, okay, to find y, which is the general solution. The general solution of the differential equation. Differential equation. So I prove it for you, so you don't have to repeat it over and over. You can use it anytime you like. But again, the warning is that integral. That you know the differential. It takes sometimes takes time, but the one that we have, you will see it. Sine function, exponential function, make it short. There are a couple of them that you may have to pay attention. So it's very easy, it takes time. Okay, any question? So recognize it, divide by x, x squared, change it to the function of y over x, call the zy over x, then you have f of z. Simplify it as much as you can, f of z minus z, then come back and do the integrations. That's it. That's homogeneous line. You ready? Let's get the example. There you are. I'll give you one on the next test. Okay, solve each equation. There are possible, a couple of possibilities. Solve each equation. And the most popular one is this one. It's not difficult, but you have to, practice to be ready for it. So that's it. X plus y dx, okay, minus x minus y dy equal to this. You see, if this equation would be given to you, you want to solve it, you just have a look. Check. It's not separable. Okay, it's not separable, it's not linear. Separable, linear, you check homogeneous first. If you can't do it, then you may go for the exact and integrating factor. This is going to be the, okay, the direction or that you check this equation. Yes.
What was that order you just said?
The order separable. It's not separable because x and the y are mixed together. They are not factors. It's clear that it's not the linear. Okay, it's not the linear. Then you check for the homogeneous before going to the exact and integrating factor. You see homogeneous, look at the powers. This is a function homogeneous of first power, okay, and the first power. So it's homogeneous. So homogeneous, simplify it and write it down as a dy over dx equal to the f of z, and you go, okay? If it's not going to be homogeneous, you check for the exact. Okay, then bring the condition m by dx. If it's not going to be exact, if you've been asked to solve it, so you may go for the integrating factor. This is the direction that you can do. If it's going to be a Bernoulli equation, they are going to tell you it's a Bernoulli equation. And we are going to have one with this type of substitution. We call it Riccati equation. Then you have a collection of all possible equation of the first thing. Okay, so it's easy to identify. So let's do it. This is it. Solution. Quickly, we recognize that the equation is okay. The equation is homogeneous. Homogeneous. So what you have to do, you have to find that a function that we're going to do. So just do the algebra the way you are going to organize it. It's going to be dx equal to the x minus y dy. So you would like to have dy dx equal to like a cross multiplication. You see the dx is x plus y, and that is x minus y. Let's make sure you get it right. Homogeneous of the first degree, so divide by x. So if you divide by x, that gives you x over x, y over x, x over x. You can do it right away, I just explained it. So the top would be 1 plus y over x. The bottom one would be 1 minus y over x. That's it. It's a function of y over x.
And so would it be x minus y over x plus one?
Which one?
Stop right there. Wouldn't it be switched? Like,
No,
wouldn't
no,
it
you
be-
see x plus y times dx. When you cross multiply, you should get the original one that we have. Okay? Because the original one is this, you see, x plus y. You write dy dx, dx, x plus y. And the other one is dy. Okay, any question? So quickly change it to the z. So z is equal to the y over x. Identify f of z. F of z, you go to this function and you replace y over x by z. So that give you 1 plus z. Okay, 1 plus z over 1 minus z. So this is going to be your first action. Now you know the solution. Okay, so the solution is what? ln of the absolute value of x equal to integral of dz over f of z minus z. So you have to form and get this integral. Any question? Because we already proved it. You don't have to go back and you can substitute again. The operation that I did, do it, you end up with this one. You already done it, okay? So you have to find this integral. You better simplify it first. Find f of z minus z, use the reciprocal. Any simplification, come back get this integral, okay? So I'm going to work on f of z minus z. So what is going to be f of z minus z? F of z minus z, with algebra involved, this is your f of z, 1 plus z over 1 minus z minus z. Find the common denominator. The common denominator would be 1 minus z. Okay, so the top is going to be what? It's going to be 1 plus z minus z times 1 minus z. Okay. Simplified carefully. Will be equal to what? Is the 1 plus z. Multiply negative z plus z squared over 1 minus z. The z and the negative z will cancel out. So you end up with what? So f of z. Okay, f of z minus z is equal to the 1 plus z squared. 1 plus z squared over 1 minus z. 1 minus minus z. So this is going to be your f of z minus z. Any question? So consider the reciprocal that give you the one that you are going to find for the integral over here. Okay, so consider 1 over f of z minus z. Flip it, so that give you 1 minus z on the top, 1 plus z squared on the bottom. This is the one that you have to integrate. Inside the integral, you see is the 1 over f of z minus z. So simplify it as much as you can. Now go for the integrations. Any question? I'll go to the next page and integrate dz. I'm going to integrate this one. You come back and you put it over here, and then do that. Okay, so the next step is going to be how we're going to find the integral of. It's the integral of the dz over f of z minus z is equal to 1 over f of z minus z. We already simplified it. Okay, so that was the case is the 1 plus z squared. Okay, over 1 minus z and the dz. This is going to be the case that we have.
Isn't it the opposite?
Okay,
Isn't 1 minus z on the top?
I'm sorry. Yes, you are right. Yeah, because I did reciprocal over there. Okay, that's it. Yeah, I rewrite it so that now it's going to be 1 minus z, 1 plus z squared dz. You have to find this integral. Any suggestion? Yes.
U sub z squared.
Oh, okay. You have to do something else first. Yes.
Factor 1 plus z squared.
You cannot factor 1 plus z
minus
squared.
z.
Who said that?
Separated.
Separated.
Yeah, separated.
Separate. See, 1 plus z squared, you know that by itself, it goes with the tangent inverse. If you have a constant on the top, 1 plus z squared is a tangent. If you have the z on the top, you have to use the natural log.
What?
That's natural log. ln u prime u. You see the constant 1 over 1 plus z squared is the distributive of a tangent inverse. Then you have a leftover of a z over 1 plus z squared, u substitution that gives you 2 prime u on the top, and we get it. Okay, so it's a very, very popular case. So we're going to break it into 2 parts. Okay, it's going to be equal to, I'm going to break it, let me write it down for you. It's going to be 1 over 1 plus z squared. This is one of them. The other one would be minus z over 1 plus z squared. dz. Okay, so this is what would happen. 1 over 1 plus z squared dz, the first one, minus z over 1 plus z squared dz, the second one. The first one is tangent inverse and inverse of z. That's the first one. The second one, you see, if you take the bottom one to be u prime would be 2z. So you need a 2 on the top. Natural log. You can do the substitution, but you don't need it. So it's going to be, we change it to the negative 1/2 integral of 2z over 1 plus z squared dz. See, this is going to be your u and the top would be what? Your du. So your du. So you integrate 1 over u du, which is the natural log. Okay? So now this is going to be tan inverse of z minus 1/2 ln of the bottom. 1 plus z squared. You don't need the absolute value because 1 plus z squared is a positive number. But remember constants. So this is the integral to the right. So what's going to be the solution of the equation? Remember, the solution of the equation. Remember, it's ln of absolute value of x equal to whatever you got over here. So that gives you tan inverse of z minus 1/2 ln of 1 plus z squared plus c. Not done because your equation is in terms of, you have to find the y. This is z. You just replace the z by y over x. So we replace the z by y over x. So ln of the absolute value of x equal to the tan inverse